Okay, today I will show you my homework chapter 8.2 to you. It's about Laplace transfer function. Okay, so you can see the title is Laplace transfer theory and application. Okay, so you can see the table of content. We have experiment objective and significance, fundamental theory, definition and the properties. Problem 1, Laplace transfer of an integral. And problem 2, Laplace transfer of a product. And problem 3, solve a definite integral. And then the summary and the conclusion. Okay, so you can see the experimental objective. The master the basics, understand the definition and the core properties, iterative, differential integration, frequency shift of the Laplace transform, and complete transforms of common function, and handle integral forms. Learn to solve Laplace transform involving integral expression, grasping the logic of interchanging the order of integration and the transformation, and solve product function. Master method of finding the Laplace transform of um, products of trigonometry and power functions using frequency shift and S domain, differentiation properties, and connect to the improper integration. Understands the relationship between Laplace transform and improper integrals, converting infinite integral into algebraic operation for verification, and experiment significance, mathematical foundation. The Laplace transform bridge time and frequency domains, sampling complex differential problem into eligible ones, and engineering application, indivisible in circuit analysis, control system, and single processing. Used for fleeting in IoT and PUC control, and skill development, honors analytical skills, particularly in handling complex functions and understanding convergency conditions, and fundamental theory definition. You can see the transform formula. mm, when this is a complex variable and the integral must converge, and the key explanation, this transform convert a function of time into a function of the complete frequency. The convergence of the integral is circular and depends on the behavior of ft and t approach infinity. Okay, so you can see the key property. The Tn equals to S n plus 1, and E, you can see the sin t is S plus 1, and linearity integration, you can see the frequency shift and the differential. Okay, so let's solve this three problem. You can see the question 1. Okay, so step 1, we simplify the integrand. Since x is a constant with respect to the integration variable u, we can split the integral like this. Okay, then first term we use the x2 minus x, and multiply the c dot t, and the second term we we use the int function. Thus, the function simplified to this one. Ft equal to tx2 minus x plus 1 minus e minus t. Okay, so we apply Laplace transfer function. We apply the Laplace transfer function linearity and the standard privacy. You can see it. Then we combine the result and we simplified it so we can get the answer. Then we do the question 2. Okay, so you can see the method I put it in up. You can see the differential in its domain. Okay, and then the step 1 we identify the function ft. We let it sin t, and the transfer function fs equal to 1 multiply s2 plus 1, and order the n equal to 2. Then the step 2 definite. You can see. Then we can get the final result. Okay, so let's solve the problem 3. Okay, so we need to find the transform first. We use the differential property, and we apply frequency shift. Then we improper integral, and then we can get the final integral. Okay, you can see the. Okay, so let's the summary of conclusion is the problem 1 is highlighted the use of integral and integration property to simplify and transform integral expression. The problem 2 is demonstrate the power of the differential in its domain property of for handling product of power and trigonometry functions. And problem 3 is showed how Laplace transfer function provide a shortcut for evaluating improper integrals and their relation to traditional integrals by part. Then the key takeaway: Laplace transform simplify complex time domain problems into a algebraic problem in the S domain, making them indispensable in mathematics and engineering. Okay, that's all. Thank you for your listening.